Congruence proofs. A proof in mathematics needs us to do more than just say, hey, these triangles are congruent because side angles side or whatever. If we want to say they're congruent because side angles side, we have to show these two corresponding sides are equal, those two corresponding sides are equal, these two angles are equal, therefore. So this is an introduction to proofs and proving that two triangles are congruent. Now there's some useful information that we already know, but that we have to just remind ourselves of. So the angle sum of a triangle is often useful. And of course, that's 180 degrees. So sometimes we might have to find an unknown angle in a triangle to be able to show that two angles are equal. Vertically opposite angles are equal. And vertically opposite angles are when you have two straight lines. Those two are vertically opposite, and these two are vertically opposite. So those two are equal and those two are equal. And incidentally, on a line, of course, those two would add up to 180, as would those two. And then, of course, we have angles within parallel lines. So when you have a pair of parallel lines and what's called a transversal, then remember, we've got two types of angles that are equal. We have alternate angles. Alternate angles are opposite sides of the transversal, so here and here, or here and here, inside the two parallel lines. We have corresponding angles, and corresponding angles are in the same position relative to the two parallel lines and the transversal. So for corresponding angles, those two, those two, those two, those two. Any pair of corresponding angles are equal. And we have co-interior angles, which are both inside the parallel lines on the same side of the transversal, and co-interior add up to 180 degrees. So we should know all this already. We should remember that from year 7, I think. Just reminding you that we know all those facts and they can be really useful. So here's an example proof for you. It's asking you to prove that triangle WAP is congruent to triangle MAC. So our proof starts, it's pretty simple. I mean, we can see we've got two lines in common here, two corresponding lines or sides that are equal here. And so we say that WA, or AW if you prefer, is equal to AC. If we want to be really perfect, we can put a little line above it to say side AW and side AC. That's fine. They're corresponding, they're in the same position. If you imagine this triangle here being rotated around, that side ends up over here. And because that was stated on the diagram, those two little lines say this is the same as that, what we say is given. Because for everything we say, we have to say how we know it. I know those two are the same because the diagram told me. Now, this angle here is the same as that angle here because they're vertically opposite angles. I can't just say angle A because angle A could be any one of those four, so I have to give the angle its proper name. Angle WAP is equal to angle. Now, if you if you can, try to keep them in the correct order. In vertically opposite triangles like this, that angle there corresponds to that angle there. You think of it as being rotated around. It's not flipped, it's rotated. That would end up here. So keeping the letter order is pretty good form. I said W-A-P, so I'm going to go C-A-M. Now, I know those two are equal because they're vertically opposite angles. And I say that. So now I've got one pair of corresponding sides are equal, one pair of corresponding angles are equal, and I look for what else I can find. There's often a few different options. So because I've got parallel lines, either of these could act as a transversal. So let's just pick one. This angle here must be the same as that angle there, and they're corresponding angles, because if I rotated this around, that would end up to there. And they must be the same because they're alternate angles within parallel lines on that transversal. So I say that. Angle WPA equals angle, now I started at W, so I'll start at C, CMA, remembering that M goes in the middle because that's where the angle is. And I say why? Because they are alternate angles in parallel lines. So now I've got 3 bits of information. Is it enough? I've got angle, angle, side. Yes, it is. So you say, therefore, triangle WAP is congruent to triangle MAC because angle, angle, side. That's a formal proof to prove that those two are congruent. One thing you might find sometimes with proofs is that instead of saying this side equals that, they might say this side is congruent to that. That's fine too. I tend to say equals. One more example for you. Now one of the reasons that congruence proofs are useful is that they can be used to prove that I've found a particular unknown. So this is asking me to find the value of x. Now you can see it's going to be 3 centimetres. But it's different to see it's going to be 3 centimetres, of course it is, and prove that it's 3 centimetres. So we've got to start by proving that these two are congruent, because if they're congruent, then those two sides are matching and they must be equal, and so that must be 3. So we look at what we have. I've got 2 right-angled triangles, which says I'm probably going for a right-angle hypotenuse side, but you never know. See what we have. Angle A is equal to angle C. Now there's no possibility of A and C being anything else in those triangles, so it's okay just to say angle A equals angle C. But of course we could have written angle BAD equals angle BCD. That would be fine too. And that was given to me in the diagram. Side AB is equal to side AC. Oh, sorry, BC. AB, BC, right? Side AB is equal to, now I did go AB, so I should probably go CB to keep them in the same order from right angle to here. Given. Now here's a different sort. This side, if I separated that out into 2 triangles, that side is the same because it's the same side. It's in common between the 2 triangles. So when you've got a side that you know is the same for each triangle because it's actually forming part of both, we say BD is common. And that's saying BD is the same in each triangle, and it counts as a corresponding side that is equal. And so now I've got, it's a right angle. That's the hypotenuse because it's opposite the right angles, and one other side. So I can say, therefore, triangle ABD Oh, we know that sine, do we? Three dots in a triangle for therefore. Because of this, I can show that triangle ABD is congruent to triangle CBD because right angle hypotenuse side. Now, because I know those are congruent, therefore I also know that AD is equal to CD because their corresponding sides in congruent triangles, and because I know that AD equals CD, therefore CD equals 3 centimeters because AD equals CD. So you can see it's getting pretty pedantic. We're really going, yes, I know this, this is why. Yes, I know this, this is why. Yes, I know this, that's why. And because I know those three, I can prove that. Proofs get a lot more complicated than this. This is your introduction to mathematical proofs.